All right. Well, we are going to get moving here. I just wanted to let you guys know that we are recording this webinar for repurposing down the road with your social media, things like that. But I wanted to say thanks for joining us on the Viaflex product series webinar. Today we're going to be we are working hard on is we do have our own in-house reclaim facility. So any of our internal scrap, we are trying to reprocess and reuse to help reduce our footprint. different in the scheme of things.
So we're going to talk about EVOH and polyethylene primarily as a co-extruded film structure. So, so the importance here, so EVOH itself is what's called a polar molecule. So making it very good at blocking non-polar contaminants such as your common VOCs, your chlorinated VOCs, oxygen, some of the similar things like radon, methane, that kind of thing. Polyethylene is a non-polar molecule, which makes it great, primarily for blocking water vapor transmission, and we'll explain later in the presentation here why combination of these two is so potent. So what is EVOH? Many people have heard of polyethylene, but EVOH is a little bit more obscure. It's a semi-crystalline polymer with a primarily an ethylene background with hydroxyl groups on it. The crystalline nature of it serves some negatives. It is brittle. It does make some of the physical properties a little more challenging. But it is an excellent vapor barrier to things like gasoline, oil, solvents, typical hydrocarbons. In areas of the country like South Dakota, we've got a lot of radon that naturally occurs in the ground, so it needs to be remediated at times. PFAS is being early studies, but is definitely showing promise in slowing the transmission rate of those types of compounds too. So.
And with that, EVOH is much more common than a lot of people think. There's a lot of different applications. Some that you use on an everyday basis. EVOH is commonly used in food packaging, not only to keep meats and things fresh longer, but also for keeping in the smell on your Folgers coffee. Other applications that you use on a daily basis are your fuel tanks in your vehicle, and then other chemical containers that are commonly found underneath your sink to contain smells, so they're more palatable.
So we talked earlier about our production capabilities being industry leading. The image on this screen is a diagram of a 7-layer blown film line. So why is this important? So I'll do some explaining here. So if we start at the top, call it the 11 and 1 o'clock positions, that outer PE layer, that allows us to put potentially a different grade of polyethylene in, or additives such as anti-skid or anti-block, or different things that could make it more abrasion resistant. As you know, many of these are used in construction applications, so fairly demanding installation with driving, dropping tools, dragging things across it, pouring concrete on it. So you may want that outer layer tougher. At the 9 and 3 o'clock positions, you've got a strength layer. So as I mentioned, the EVOH can be brittle. It can have some degradation to physical properties of the film. So you can use these layers to improve that, improve your impact resistance, improve your tensile strengths. We have different lines, may have different percentages here, so we can really design to meet your needs. As we mentioned, polyethylene being a nonpolar and EVOH being a polar molecule, they're kind of like oil and water. When you try and co-extrude them without some assistance, they will peel apart relatively easily. So the layers you see at roughly the 7 o'clock and 5 o'clock positions are tie layers. One common tie to use would be on lake anhydride treated polyethylene. This creates a chemical bond between the polyethylene and the EVOH so that they won't peel apart, so that they do stick together and form one continuous film. And then at the heart of it, the 6 o'clock position there is the EVOH layer, and that's your gas barrier layer. Again, just to reiterate, this combination is going to block water, it's going to block radon, it's going to block your VOCs. So you get the best of both worlds out of this.
Yeah, and then to help kind of add on to that, so Chris's previous slide depicted what the film looks like when it's being blown up in our extruders. This slide, I like this illustration as it gives what the finished panel would look like with the EVOH and the PE layers tied together in the middle with all of that outlined in the slide before.
So to get into some of the data around benefits to using a co-extruded film. So this, Raven, when we were Raven, we commissioned a study with Queen's University with Dr. Batista and Rowe. This ended up, it was intended to be a shorter study, ended up taking about 6.5 years to complete, and I'll explain why. But this slide kind of depicts the methodology, or a little bit of it. So on the picture in the bottom right is one of the chambers that was designed and built to test this. And so on one side of this chamber, you would have a reservoir of an aqueous solution. In this case, it was trichloroethane, is what the graph represents. And then on the other side of it, you would have just a distilled water reservoir. They would be separated by a film. In the case of this, they use high density polyethylene films of 60 mil. They used just straight EVOH films of a couple different mole percent EVOH, and then co-extruded film of polyethylene tie EVOH, like we demonstrated in the previous two slides. And they were sealed with Teflon in between the layers, and they were kept at a constant temperature. And then samples were pulled from each side or each reservoir at varying intervals to test for the concentration. So that graph on the left is a depiction of that for the 60 mil high density polyethylene film. And the x-axis, or the y-axis, is the percent of original concentration, and the x-axis is the time in days. So as you can see, we're nearing and reaching equilibrium between the two chambers, somewhere around 60 to 80 days. If you're going to put this material under a concrete slab to protect your structure from harmful vapors, 60 days isn't very long in the time frame of a building. So kind of as you'll see in further data, the importance of doing a co-extruded film.
Yeah, and on that note, so this is one of my favorite graphs, because in the construction market, in this industry, when people are working on brownfields or contaminated sites, there's a common misconception that we run into a lot, that the thicker the membrane, the better. However, a lot of times when you get into some of those thicker membranes, for instance, in the illustration here, we used a 60 mil HDPE geomembrane as an example on some testing that we've done. So with the mentality of thicker is better, this shows that our product as a 20 mil is almost 300 times more compliant with ASTM E1745 on that vapor transmission than an average 60 mil would be without an EVOH tie layer within that. So with that, it's important for us to be meeting that ASTM E1745, because it's giving you the strength properties, it's going to give you the puncture properties, but more importantly, when you're dealing with contaminated sites, it's going to give you it's going to stop that permanence of those VOCs that are intruding into that facility or that building.
So this table is more of a tabular, I guess, depiction of the previous slide. The permeation coefficients that were developed throughout the nearly 6.5 year study, and it didn't really mention why it took so long. As we got into the co-extruded membranes on the far right there, they were planning for somewhere around a 6 month to a year to try and develop the coefficients, and the data was barely moving. So they ended up continuing to extend it out until they were reaching a steady state or close to steady state to extrapolate these coefficients from. This table, if you start on the left, so in the case of a permeation coefficient, lower is better. You're trying to keep this material out. So I'm not going to read the units there. You could read them yourselves, but it's a unit of flux. So if you look at the left, you've got a linear low density membrane, high density membranes, followed by the two EVOH, just EVOH thin films at varying mole percents, and then our co-extruded membrane that we depicted earlier in the presentation. So as you can see, if you're nearing 300, you're in the hundreds to almost 1,000 times lower permeation coefficient. So it's gonna slow the material that much more than the worst case scenario of either linear low density or high density polyethylene. So really pretty remarkable technology, considering it's about 1/3 the thickness of those two membranes. On this, so we've begun doing there's some early testing going on, looking at the fluorinated compounds, the PFAS compounds. The data is early. We've only got comparisons for just co-extruded EVOH and linear low density, but even on those, you can see your 1 to 1.5 orders of magnitude lower permeation coefficients, so that much better protection, 10 to 15 times the protection for your structure and the occupants of those buildings from these types of compounds.
So continuing on with some of the testing that we've done with our VVP 20, as mentioned, Viaflex, formerly Raven Industry, being industry leading in quality is of the utmost importance for us as an organization. So with that, in 2019, we actually did our own internal study here, utilizing VVP 20 as well as other materials. Those blocks that you see on the screen are geofoam. So what we did here internally is we wrapped a number of different samples in not only our material, but as well as some of our competitors' material. And then we fully submerged those samples into gasoline. Chris, do you know how long they were submerged in the gasoline?
So some of these were on the order of days. Some of them were on the order of months. So when you look at the top rows, you can see how that block is either being dissolved or it's shrinking. And if you've ever seen gas in contact with foam, it basically dissolves it almost instantly if you put it in there. And so reading the thing, you've got starting at the top, PVC, linear low, EIA, I can't remember, read real well. Then chlorosulfonated polyethylene, high density polyethylene, and then the row F is actually our VVP 20. So the pouches that were made to contain these cubes, like as Chris mentioned, were fully submerged in gasoline. I believe the ones on the bottom were on the order of months. And as you can see, there's very little deformation of those geofoam blocks, especially as compared to the others. Primarily, that's likely coming from the welds, as they were a PE to PE weld, so they're going to allow some level of transmission in that seam, but there's almost no damage to those blocks, as you can see.
Yeah, and any of the studies that we have referred to throughout the course of this conversation, we'd be more than happy to provide any of that information to you after the fact and chat with you about any of those results or questions that you may have. So with that, VVP 20 isn't necessarily the only product that we manufacture that has an EVOH layer in it. We do manufacture an absolute barrier series of thicker products. However, one of the things that we like to point out about the VaporBlock Plus 20 is the ease of use and installation. We do have a tape that makes this for easy installation. Any general contractor can use the 2-tape system to install this. If they have any experience doing underslab, which I'm sure they install vapor barriers all the time, any GC can do this. When you get into some of the thicker products that we offer, you're really going to need to be heat sealed, and those typically come with the need of a professional team to do that. So we have all the accessories for both the heavier and the thinner stuff, but we provide all the installation guides and all of the accessories you guys would need to quote out or to spec any project. And with that, we've covered a lot of information. Are there any questions that you guys have for us before we wrap it up? I think that's probably a pretty good sign.
So,
okay, we got 2 questions. One is, can you go back over the benefits that VaporBlock Plus offers in the construction field when installation? Does it take a special team to install? Can be done by anybody. Can you walk us through that again, please?
Yeah, absolutely. So the question was, what does it take to install this product? And as I mentioned, if there's a general contractor out there that is working on flat work or doing any type of concrete work, if they can install a standard vapor barrier, they can easily install this. The only difference that you're going to find with the VVP Plus 20 versus a standard barrier is it comes with a 2-tape system. So the first tape is a double-sided butyl tape to help seal the seams. And then we actually have a tape that has an EVOH layer in it to go over those seams. So it's a little bit more work on the taping side of things, but really any GC that has any experience can do this. As it goes for the absolute barrier, when you get into the 30-40, that's going to be a little bit more difficult because some of those wedge welders and heat seamers that they're going to need, it's typically pretty expensive equipment, and we'll require a special crew to do that to ensure that all the seals and seams are done correctly. What was the second question, or did I cover it, David?
There was a question that came in. You mentioned thinner, lighter, stronger. Now, the person's asking, you kind of mentioned about if you went a 60 versus 20, the 20, not necessarily are they compatible like in strengths.
Yep.
Can you go over that again one more time? Like how R20 compared to a 60 non-VOH works?
Yeah, do you want to start on this?
I can, yeah. So the polymers that are used in designing the 20 mil film provide for all specifications for E1745, which is your underslab vapor barrier, ASTM, are met and exceeded without having to go to a 60 mil product. So the 60 mil HD, it does meet all those also. You're just not gaining all the benefits of the extra barrier protection from all your VOCs, your chlorinated VOCs, and other potential contaminants. So you're using basically 1/3 of the material, meeting all the same requirements and exceeding all the same requirements, but gaining obviously a lot here. Plus, it's a lot more flexible, a lot easier to work with, obviously 1/3 the weight, so manhandling it, less equipment needed to actually install it.
Perfect. Those are the two questions that came in.
Wonderful. Any other questions before we turn you guys loose? Awesome. Well, thank you guys for joining. And if there are anything else, please don't hesitate to reach out to us, and we'll get any other questions that come up answered.